Hey, I'm Russ.
I'm Will.
And today we're talking SCHMIDT about the moon.
Spoon!
Thanks for checking out Talking SCHMIDT, where we discuss the ways that different marketing technology is shown in different forms of media. And today we're going to talk about the 1992 animated show, The Tick. Was it 1992? We're talking about the episode in which Chairface Chippendale tries using a laser to put his name on the moon. And we'll see how it goes.
But after tonight, they will never forget my name. Professor Chrome Dome, prepare to fire! Ready when you are, Herr Chippendale. And you see, new batteries even.
It looks like what they're planning on doing is using a flashlight and magnifying it to create a laser. That's not really how lasers work, right?
Correct. Without getting too much into the detail, laser is actually an acronym for light amplification by stimulated emission of radiation. Lasers are made by manipulating the electrons in atoms to emit energy in the form of photons. And so, like you said, what we've got in this device here looks like some magnifying glasses powered by a flashlight. And while the end result might look similar to our laser devices, in that they both produce a beam, the processes are actually quite different. This light source being the flashlight. Flashlights are referred to as white or normal light. And laser light is monochromatic or contains a single light frequency. So differences that you might see, a laser wouldn't produce a rainbow like you see with normal light. Even a flashlight can produce a rainbow if you shine it through misted water.
Yeah, so this is more like what you would do at home in your backyard with a magnifying glass in the sun and
Correct. I think everybody does it as kids. You know,
I never did, but only because I didn't have a magnifying glass.
Right. You're at least burning paper or burning dried leaves or anything like that. So you can get heat, but you're not going to generate a laser.
Here, they're actually kind of laser marking. I mean, putting aside the fact that this isn't a laser, what you're seeing here is actually a lot like the way laser markers move and work. The difference is that with laser marking, we're talking about depths of 10,000th of an inch. And so I think technically deep engraving is considered anything deeper than 5,000th of an inch, which isn't very deep at all.
Right.
Here, in order to mark the moon, I mean that mark must be hundreds of feet deep if it's going to be visible from the Earth.
That's very true. That's something I didn't think about. If it's going to be visible, it's going to be so deep.
Yeah. And actually, talking about our previous video, where we were discussing whether or not a planet would explode if it got hit from a giant laser from space. This isn't a giant laser from space, it's a giant laser from Earth, but it's hitting the moon and it's not exploding. Now, it's a cartoon, so that doesn't really mean anything, but I think this is actually what would happen if Earth got hit by a giant laser from space. The shape of the moon presents problems for laser marking. It's round, and so the focal distance is going to have to change, right?
Correct. Different lenses, depending on the different sizes, will have a different focal range. Once you get out of that focal range, once you get out of that set distance, then you're no longer going to get a mark.
Actually, here. Okay, I'm back. Will's here too, behind us. There he is. Okay, so firstly, laser beams they're cone-shaped, essentially.
Correct. It's not a true beam.
Right.
Right.
The laser, so if the lens is up here, the laser comes down in like a cone shape. And what it does is it comes down, but then it doesn't just stop, it keeps going. So it makes like an X. And so what you get is this 3D shape just like this. And in order to get a really good mark, the thing that you're marking needs to be right at the center, right where these two cones meet. For flat parts, that's not an issue. You
Correct.
figure out how far it is, you put it there, and it can mark along that distance all day long.
Correct. Within its certain marking field.
Yes.
Correct.
Yes. But for something spherical, in order to mark, for example, down here, that's a different distance than it is up here. And so you need one of two things. You need a laser that can make that adjustments on its own, or what we offer are rotary devices.
So pretty much what a rotary device is going to do is it's going to know how the spacing of your characters and how far that mark is from off-center, from its focal distance. So it knows I need to index or turn this many degrees in order to keep that focal distance within focal range.
And then there's also the issues of craters.
Which is something I was going to bring up, but yes, craters would create a big problem too.
Yeah.
I mean, if you really want to get technical, if this laser were to exist, the lens would have to be so large that I don't know if craters would actually really be as big of an issue as the actual curvature, because you do have that certain focal range.
That's true.
And so the greater the laser you get, the greater the focal range. This laser would have to be giant. So I'd assume that your focal range would be pretty great. And I don't know what the biggest crater on the moon is. So I'd assume that your focal range would probably be a couple feet, if not a couple 10, 20, 30 feet. So there is that idea.
Well, let's find out. 4.5 kilometers deep.
Oh, so yes, you would probably
Couple miles.
Yeah,
Yeah.
you would, craters would cause a problem.
Yeah. So that's it for this Talking SCHMIDT. Thanks for checking it out. If you liked it, we would appreciate it if you hit the like button and also subscribe. Oh, actually, you know what? We've gained a few subscribers.
Good.
In the last month. So thank you to all of our new subscribers. We're at 899 subscribers, but we'd like to get it even larger. And so we're trying to get to 1,000 likes. If we get to 1,000 likes, I have a fun kind of special video that I don't think we'll get in trouble for.
Okay. I like the sound of that. Let's get to that 1,000.
So let's get to that 1,000. So hit like, hit subscribe, and let us know what other movies or TV shows or comic books, video games, anything that you would like us to discuss when it comes to lasers and other marking technology.